There's many ways that we can separate mixtures into their components. One thing that we can do is chromatography, and that's involving a stationary phase and a mobile phase. And so the mobile phase is moving through the stationary phase, and it's pulling apart the components of the mixture based on polarity. And so there's a lot of different ways that you can go about doing it. You can have an HPLC setup, which is a little bit more advanced, and then you're going to maybe get some readouts that look like this. But you can do it simply with some toilet paper, and we'll see that soon. We'll see the water as the mobile phase moving up through the toilet paper, which is the stationary phase, and it's going to be pulling apart some ink into its components. And so you'll notice that black ink is actually not very black sometimes when you get down into the components of it. And then we can also look at Kool-Aid, and we can separate Kool-Aid into its components. And so, for example, grape Kool-Aid has red and blue dye in it, and since red dye is more polar, it'll interact more strongly with the water, which is polar. And then as you send through different concentrations of isopropyl alcohol, that will start to pull out some other colors as well. And so the basic idea of chromatography is demonstrated. Okay, so we have a mixture, and we're going to break it into its components using column chromatography. So what are we doing first here? We added the sample to the syringe already, and so now we're grabbing some water, and the sample is in the column. And so we'll push out some of it using water first. We'll see what color we get. Alright, looks like a yellow color for water. And then we'll start increasing our percentage of isopropyl alcohol. So we got 8.25% alcohol being pushed through. You can start to see the orange coming out now. Bump it up to 17.5. All right. 35.5. Got a little bit of a bluish tint to it. And then 70%. All right. So all of that was in that, and you have other mixtures that produced these.